Hello and welcome to this quick video about drawing quadratic graphs. So this is specifically about drawing quadratic graphs by hand. I want to quickly recap to you what quadratic equations are and what quadratic graphs look like. So a quadratic equation has this general formula down the bottom here, ax squared plus bx plus c. And these values, these c, b and a values, are numbers that are given to you in the question. When you graph a quadratic equation, it could give you a graph that looks a bit like this. So this graph has a curve to it, and that's very important to recognize. It goes up, it curves around at the top, and it comes back down. There is either a maximum point where the graph has a high end, or if you can imagine this graph flipped, there would be a minimum point where the graph comes down, has the lowest number, and then goes back up again. The important thing is that these graphs curve. They are not a straight line. Just on that, there are two types of quadratic equations, quadratic graphs. There are positives, where it goes down, and then it hits a minimum, and then from there it comes up. So a positive starts going down, hits a minimum, and then comes up again. And a negative graph. A negative starts going up, hits a maximum, and then goes down again. So positive, down, then up, a negative, up, then down, and there is a maximum on the negative and a minimum on the positive. So how do we draw quadratic graphs that look like this? By hand. These were done using Desmos, but how do we do it by hand? The easiest way to do it is with a table of values like this and a calculator like this. We have been given this instruction: graph 2x squared plus 3x take 1. It wants us to graph this equation. This is a quadratic equation. It follows the general formula of ax squared plus bx plus c, or in this case minus c. Now oftentimes you will have to set up this table yourself. And I always recommend to have these as your x values initially. -3, -2, -1, 0, 1, 2, and 3. And that is because that gives you equal space on both sides of our 0, so you can see where the graph is heading. Now what we do on our calculator is we take this -3 here as our x value, and we put it into our equation where the x's are. We are replacing these x's with this x value. Something else that I always recommend is to put brackets around these x values, or around these x values, when you put them into your calculator. That tells your calculator that they are multiplying and that they are in place of this x. I will show you. 2 bracket -3 squared plus 3 bracket -3 close bracket minus 1. So if you look at this, this shows the same thing here, but it has our -3 as the x values here with brackets around the -3's. When we press equals, we see that that is equal to 8. So we continue this. Our next x value is -2. So I can go back into my calculator and I can change this -3 in that first bracket for a -2, and I can change this -3 in this first bracket for a -2. And that gives us 1. We keep going. I go back, change this -2 to a -1, change this -2 to a -1, and we get -2. We continue this for all of our x values that we have given ourselves. So after 0, we go to 1, not -1, 1. 2, And finally, we replace our 2 with a 3. So replace both 2's with a 3, and we get 26 for our last one. So now we have these from our calculator. What do we do from here? Well, oftentimes you will be given what is called a Cartesian plane. And this has our x-axis along the side here. It has our y-axis going up and down. And it has all the numbers, negatives to the left and to the bottom, positives to the right and to the top. And our job is to take all of these points that we've got and put as many of them as we can onto the graph that has been given to us. So I've done that here, and let me walk this through to you first. We've got x is -3, so I go on the -3 on the x, I go to -3 on the x, and I go up to 8 on the y, because -3 is 8. Then -2 is 1. -1 is -2. 0 is -1. 1 is 4. And 2 is 13. 2 is 13. But we don't have a 13 on this. This doesn't go high enough for 13. So we don't worry about putting a dot there. The same thing for 3. 3 is 26. We've got 3 on the x-axis, but this only goes up to 8 on our y-axis. So we can't go up to 26 or 13, so we leave those two off. Once you have got these dots, you need to connect them up. But remember that quadratic graphs curve. Quadratic graphs curve. They do not go in straight lines. So when we connect these dots up, we're not just going to go straight to this dot with a ruler, straight to this dot, up to this dot, and then up to this dot. We need to curve them together. And sometimes that means going below and then back up. Sometimes it means going above. But we need to, as best we can, with a steady hand, draw a curved line that connects these up. It should look something like this. So I've drawn a curved line that goes down through these dots, It bends a bit down the bottom here so that it can travel back up. Remember, it's a bend, it's not a corner, it's a bend. And it goes back up through these dots and off it goes. That is not perfectly this equation, but considering we only had 5 dots, it is good enough. And if you only have 5 dots or 4 dots and you get something like this, that is good enough. It should look something like this if you were doing it on Desmos, and you can see that it is very close. Our minimum is just below -2, which it is the same here. It crosses over the x-axis just before -2 here and just before 0 here, which happens here, just before -2, just before 0. So it's really close to what the perfect line would be. That is how we draw quadratic graphs from quadratic expressions using a table of values. It is the easiest way to do it to make sure you get the most accurate line, the most accurate curve.